lesson. All right, we've got a lesson period 3 tomorrow, and I don't want you have to be on your laptop at all. All right, I don't want you coming joining a meeting. I don't want you having to log in or anything. Okay, so I want you to pick up today, understand today what you need to do tomorrow. Okay, and then I don't want you inputting it. I don't want you feeling you need to let me know the answers tomorrow. I want you during Thursday's meeting just to pop it into the chat on the side. Okay, so the first two here we're doing consistently across the maths departments because it just allows us to collate some data that we can go and use when we're doing sort of analysis. You know, when we're doing examples. I mean, we wouldn't use your names, but you know, we could be doing stuff like group data and stuff, and we could say 40 people are asked to see how many tennis ball keepy-ups they could do, and 5 of them could do it for 10 seconds, 10 of them could do it, that sort of stuff. So this is what this is your mission for tomorrow. Okay, number 1, I want you to find a tennis ball or a small ball if you haven't got a tennis ball. So not a football, not a beach ball, nothing easy. And I want you to see how many keepy-ups you can do. You know, that's when you just keep kicking it and just keeping it off the ground in a row. Okay, you can have as many goes as you want, but I want you just not to spend more than 10 minutes on it. Okay, so that's quite a physical one. Then the second one, again, quite physical, I'm afraid. How many star jumps can you do in a minute? Okay, you know what a star jump is. So there's that one. And then I've gone and changed the third one because I thought the third one wasn't quite fun enough, really. So this is the biggie. All right, I want you to make your best paper aeroplane. All right, and throw it and roughly measure how far you think it goes. I don't mind whether you want to just sort of do it by steps and just sort of estimate it, or if you've got one of those sort of long ruler thingies that you can sort of, I forget what they're called, no, one of those tape measure things that sort of comes out of that little plastic bit. It's like the metal thing. If you've got one of those, that would be good. And if you're very proud of your plane and it's been super successful, you're very welcome to send in a picture of your creation. Okay, so those are the 3 things I want you to do tomorrow during our maths lesson. So I don't expect to see you, but I do hope you actually find time to do those 3 things. So they're slightly mathsy in as much we can get some data from it, but they're not that mathsy. So that's tomorrow sorted, and obviously this is being recorded, so if you want to just go back and remind yourself of the 3 challenges, I'll do so. I will go and do a post, so I won't schedule a meeting, but I'll post on Teams just to remind you of the 3 things. So over to today's lesson, and I'll wait for it to click around. We're going to be doing probability trees. So let's see how long a lag we've got. Oh, not too bad. Now, so we're going to be doing probability trees. What we did last year, okay, what we've already done was what was called frequency trees. So this isn't what we're doing today, okay, but I just want to remind you what they were, just so you don't get in a muddle between the 2 different things. All right, they're both trees, but they're different types of trees. So what we did last time was a frequency tree. So I'm just going to quickly remind you what we did last year. So say there were 30 pupils in a class, of which 16 are boys. Okay, so we'd say 16 boys. I know there's a lag, but it'll come through in a minute. And if there are 16 boys and there are 30 in total, then how many girls must there be? There must be 14 girls. Okay, I'm pressing on even though there's a lag because this isn't the important bit. Okay, so the first 2 crocodile mouths coming out, 16 boys. Because there were 30 pupils in the class in total, there must be 14 girls. 16 and 14 is 30. Now, of those boys, 10 prefer tea. So coming out from the boys' arm, we have 10 prefer tea. And then just sticking with the boys, there are 16 boys. If 10 prefer tea, then obviously 6 must prefer coffee. Those are the only 2 options. Okay, and then we're told 6 of the girls prefer coffee. So coming out from the girls, we'd have 6 prefer coffee. Well, there are 14 girls, So if 6 prefer coffee, then 8 must prefer tea. And then the question says, how many pupils prefer tea? How many pupils prefer tea? So we just pick up those who prefer tea. So we've got the 10 boys who prefer tea. We had the 8 girls who preferred tea, so the answer would be 18. So that's what we did last year in second form, and we're moving on to probability trees in third form. So there's only 2 I want to model. Okay, so this is the first one. So on this first one, we've got an example where 2 events are going on. Thomas is playing 2 games of chess. Okay, but the probability for both of the events is the same. So what we're saying is Thomas is pretty good at chess. So we're saying the probability he wins is 2/3. Okay, but that's for both the games of chess he plays. Now I'm going to be drawing these probability trees from scratch. You will be given the lines to start with and just have to fill in the numbers. But I just wanted to explain what was going on. Now, I want you to visualize the probability tree. You don't get this dotted line on it, but I want you just to visualize it going down the middle. And on the left, you've got the first thing that happens. Now, I'm going to call that event 1. Okay, so that's Thomas's first game of chess. Say he plays 1 game of chess in the morning, and then event 2 on the other side of the dotted line, that's Thomas's second game of chess. And as I said, none of that I've just written on the screen would be given to you, but that's what you've got to picture it. Is the left-hand side is the first thing that's going on, the right-hand side is the second thing. So let's go and think about Thomas's first game of chess. There's only 2 things that can happen. He wins or he loses. All right, we're not being given an option of a draw. So wins and loses. This is all relating to that first game of chess. Now the question tells us the probability that he wins is 2/3. Now, key learning points. By definition, think of this as a crocodile mouth. The 2 branches, or sometimes it will be 3 or whatever, all those crocodile mouth branches have to add up to a whole. They have to add up to 1 because they cover all possible eventualities. So in this case, Thomas either wins or loses, but there might be 3 crocodile mouths, in which case he could win or lose or draw. But still, the 3 would add up to a whole. So always make sure that the branches of the crocodile mouth add up to a whole. So because the chance that he wins, Thomas wins, is 2/3, the chances of him losing must be 1/3, because the 2 together add up to a whole. Now, it could be in fractions, it could be in decimals, so you just carry on doing it however they do it. So if the probability of winning had been 0.8, then losing would have to be 0.2, because they add up to a whole. Now, that's what happened in the morning. Now, in the afternoon, Thomas goes off and plays another game of chess. So what you have to do, you have to come off from whether he wins or he loses and have 2 more sets of crocodile mouths. So there's the first, there's the second. So the pair at the top is what happens if Thomas wins in the morning, and the pair at the bottom is what happens when Thomas loses in the morning. Now, for the ones we're looking at the moment, the events aren't connected. Okay, we've been told the chances of Thomas winning in the afternoon is 2/3, whether or not he wins in the morning. Okay, they're not connected. We will look at some harder ones when the events 1 and events 2 are connected, but for today they're not. So all you have to do for this today, and it should be quite quick. I anticipate most of you will get this exercise done quickly. So in the afternoon, okay, I'm just popping in purple the top one. Okay, so still the probability that Thomas wins in the afternoon is still 2/3 that he wins, and it's still 1/3 that he loses. Okay, now maybe Thomas lost in the morning, in which case you go and look at the crocodile mouth at the bottom. But we still have a situation, whether he won or not in the morning, that the chances of Thomas winning is 2/3, and the chances of losing is 1/3. So what I'm saying is the 2 branches in green, the 2 branches in purple, the 2 branches in light blue will always add up to a whole. Okay. Now let's just do a slightly different one. So we're moving on to Lottie now. Okay. Now Lottie's playing a game of cricket in the morning and a game of rugby in the afternoon. So again, just to visualize what's going on, let's break it down into morning and afternoon. So in the morning, that's when Lottie's playing cricket, and in the afternoon, that's when she's playing rugby. So go and just consider the morning. The probability that Lottie wins at cricket, so wins at cricket, we're told in the question is 3/5. So therefore, the probability that Lottie loses at cricket is whatever makes it up to a whole. 3/5 add 2/5 as a whole, so that must be 2/5. Okay, those two in green add up to a whole. They add up to a whole. Now, moving over to the afternoon, okay, when Lottie's playing rugby, the chances that she wins, we are told, wins is 6/7. That's very faint. I'm going to change colour. The probability she wins is 6/7. So the probability she loses at rugby is again whatever is left to make a whole. So that's 1/7. Now that's what goes on had she won at cricket in the morning. At the bottom, we're considering what happens in the afternoon if she lost at cricket. Well, again, with the questions telling us that they're not connected. You know, Lottie puts it down in, at lunchtime, she just sort of, gathers her thoughts and just goes and plays a game of rugby, and she's still got a chances of winning of 6/7, whether or not she won the cricket or not. So the 2 branches at the bottom are going to be a repeat of the rugby branches at the top. The chances she wins at rugby is 6/7, and the probability she loses at rugby is 1/7. Now, because we're in lockdown, it seemed easier for me just to make today's exercise purely practicing this skill. So I expect lots of you will rattle through it, and you will be needing to go and work on something else. So please don't just go and get 15 out of 15 in 5 minutes, 10 minutes, 15 minutes, and then just go and just leave, please. I want you to just be going back and finishing something. There will be some of you that struggle, and I will be having to help you, which is absolutely fine. But I don't really want to look up and suddenly see that I've got like 5 people attending. I know this is, a lot of you will find this straightforward, but it's a critical building block which we'll build upon next lesson. Okay, so let me go and stop the recording. Okay, here we go. So I would value